1, 2. Hello, welcome to a new little journey through FreeCAD 0.18 version. Before we start, let me give you some informations and talk a little bit. Number one, why 0.18? Today, before I started, I was downloading and copying the newest version of 0.19 development, and I found out we still have a major problem with 0.19. The problem is still that when you use the formula editor, which I do very often, and you want to refer to any value that has been defined inside FreeCAD, or you have defined as a named constraint or as a value in a feature distance or whatever, you have no suggestions on the name. So if you want to do this, you need a piece of paper and write down everything. And if you're not somebody who comes from 0.17, 0.18, you don't even know the internal values that you can refer to, and this makes it, for me, really unusable. So still, as long as this is not solved, 0.18 is the version to take, especially when you want to learn FreeCAD. If you don't want to use the part design, or you don't need these named constraints or any references, you probably don't even want to use the formula editor, well, you're fine with 0.19. There's a lot of new things in there which you can make use of, especially when you deal with other parts of FreeCAD. If you are going into combining this and that designs to a bigger assembly or such, then you are on the right track with 0.19. But as a beginner or as a casual user, you might stay with 0.18 still for a while until that problem is solved, because to me, really unusable in the moment. Okay, so the version of 18 that we're using, as usually I'm telling this is a version which is from 2019, October 19, 3/4 of a year old as of today, but still does everything that I need for my designs, which in the last couple of months have not been too much. I was into other occupations, so not much to design, and if there's not much to design, well, not much use of doing videos. Okay, so this is about 0.19. The next thing I want to tell before I start is I want to say thank you to all those people who have already sent me a donation via PayPal. I appreciate this very much, and that helps me to get a little bit feedback out of the work that I'm putting into these videos. They take quite a long time to make. Sometimes you have to do things 5, 6, 7 times until you are satisfied with how they are and what the value for the reader is, and all the cutting, all the removal of unneeded tones and unneeded clicks and whatever happens during recording of a video. So thanks for all those people who bought me a beer. I'm not drinking all that as beer, be sure. No, the design we're doing here today is I changed a door. I replaced the door in my old house here, and the frame of the door is not as wide as the old frame has been, and therefore now there's a gap between the door frame and the frame around the floor tiles. And to fit this gap, I need a piece of I need a 3D printed piece, and that should fit very tight into the complex gap that now appeared. The idea is I want to create a piece that I can first print out on a sheet of paper, corrugated paper or something like that, and then try to fit it or tweak the values until the paper fits, and then do a test print, just a flat test print, and again look if it will fit, and then finally do the complete 3D print and just glue it into its place. So what's the idea? How will I do it? Okay, first I want to create the three things that two things. I have the frame that lies around the floor. That's a flat frame with a smooth corner. And then I have the door frame and I have the gap. And the third thing that I'm going to construct is the filler itself, which will then be constructed according to the values that I have in my master sketch where these two frames are. So let's start. First thing is we create a new design. We're going into part design as usual. View, workbench, part design, if you don't have an icon to go there. So create a new design, create a body, create a sketch, and we work on the XY plane, the bird's eye view. I'm not going to go into a lot of details that I've already explained in other videos. So maybe if you are not sure about the things, look at my previous videos and learn a little bit before you listen to this video. Okay, so on the XY plane we first start to design. Let's create the door frame. The door frame is relatively simple and relatively straight ahead. We create a rectangle and we have to fix that rectangle to a reference point. And in this case I'm not going to do it in the usual way, which is fix it to the center point by making it symmetrically over the corners to that point. No, this time I want to do it in the way it's more like the real life. So this is a point, so to speak, on my wall where the frame ends left side, and therefore I'm gonna make these 2 points coincident. The next step is I need the width, or the depth of this frame, and that one is gonna be, let me look at my recording, that's 20 millimeters, and I call it frame depth. So the next is, here we need the frame width, and this one is 60 millimeters, and I call that frame width. Not sure if I'm going to reference this in a formula later on, but maybe I will, so it's better to start with named references for those key constraints. Good. So let's close this and let us create a first feature from it, and that feature is going to be a simple extrusion, and I want to make this intrusion, let's see, 200 millimeters high, and let's just move it a little bit. So the next is that this one has smooth corners on the side pointing into the room, and I'm going to create them as a fillet, and the fillet is going to be a, well, I think a 6 millimeters radius should fit roughly. Okay, so this is for the fillet, and let's name this body F2 key door frame. Good. So the next piece that I'm going to create is a new body, and in this new body a new sketch. I'm also going to use the XY plane, and I keep this visible in the moment just to have a reference for my thinking. Okay, let's create another rectangle. What's that? I don't need this here. Let's put it somewhere else. Let's create another rectangle, and that rectangle roughly lies here, and I take away this line because it's not exactly a rectangle what I need, because there's a little gap of the old frame that was in there. So this looks more like this. I just move these lines. Make sure this is vertical. In fact, horizontal when you see it lying on the floor. And then we have some values to key in. So this is roughly 10 millimeters of a gap. This one is also 60 millimeters. That's ground frame width. Move this a little bit away. This one gap is 15 millimeters wide. So we move that here. Good. And this point is directly on the wall. And now we can move this here. The length here doesn't matter more or less, so I just give it a arbitrary value. Let's say also 130 millimeters. And as we don't need this visible more or less, let us put this value into the so-called virtual space, so it's active but it's not visible. Good. All we need is now to define the distance from here to here, and this one is not defined on my recordings, so let me just create a helping rectangle and define a couple of values. I know that this has to be 120 millimeters long, and I know that I need some overlap here which is, let's say, 3 millimeters. So we move all of that. Oh, there was something wrong. Let's go back. The you go back with the Control Z key, Control Z. So I wonder what was wrong. From here to here, I need a distance of 3 millimeters. Okay, now it moved correctly. And I know that from here to that edge, which I have to get from its previous sketch, so let us switch the door frame fillet off, but switch on the door frame's sketch using the space key. And now we see that, and now we can create a reference, but we can't create a reference directly because we have this in a different body. So what can we do? Well, we can make a carbon copy out of this. So let's make a carbon copy and use the Control or STRG key while we're moving. And this shows the box sign, and now we can make a carbon copy from the previous sketch of the other design, the other body. It's, as we are in construction line mode, it stays in constructive mode, and now we can just add a constraint, and that constraint has to be 12 plus, let's say, 15 millimeters. Because there's another gap in the ground floor here, which I also want to fill with my later to be defined object. Okay, so that now fixes our ground frame, and let's see, we have 2 more degrees of freedom, and let's see what they are. Click it, and there we have some, yeah, just give it an arbitrary value. And what else is to be fixed? Yeah, the position itself is to be fixed also. And well, we don't even need a rectangle for that. A simple line will also do. Apparently killed the length, 120 millimeters. So it's fixed again, and we simply lock this position and unclutter by moving it to the virtual space. So we have everything we need in that sketch, and now I can take the sketch and also create an extrusion. That extrusion is to be 10 millimeters high. Before we go any further, save this by giving it a name. Call it Spacer 1. This ground floor frame is not parallel. It has some slant going along its whole depth. And as this is not a 45 degrees slant as we have in a chamfer, what we need to apply is a so-called draft. First, we have to select an edge, face, or a body. So we want to draft, or we want to apply pressure to one side of this plane to make this line shorter than here. And I estimated that there should be a roughly 5 degrees or something of a slope. So let's select this plane and then select the draft functionality. Well, first we don't see much. If we look to that from the side, we can see there was something applied, but in the opposite direction. We need this side to be lower. So first we have to define which side should not be affected, and that is the so-called neutral plane. So we click this face as the neutral plane. So what we see is now this line got longer and it moved upwards. To see these effects a bit better, we apply 5 degrees of slant, and we just play around by changing this to the neutral plane, so the front stays at the predefined height whilst the rear part moves up. But that's not what we actually want, because I measured the whole thickness and that was here. Now unfortunately it goes upwards instead of downwards, so what we have to change is we change the pull direction and it goes downward. You could also change where it pulls to if it wouldn't be a move just in the Z direction. You could also select a line for a different pull direction, but that won't make sense here. You gotta play with that function a little bit before you get crazy. Sometimes it makes me mad if I use this draft function, but if you do it correctly it works pretty well. So 5 degrees is a little bit much. I think 3 degrees is what I actually need in the end. And to make it complete, I want to have a little bit of a fillet here, which from the visual reference to the original looks like this here. And as I said, I want to experiment until I find a perfect fit finally. Okay, so if we now switch on both, we can see the actual situation as it looks in the photo, except that we don't have the hole here, and we also don't see the hole in the ground floor here. Good. So what's next? First, save. Okay, the next step is that I create the filler part, and after I have created it, I want to subtract both existing parts from it to have the final piece. So let's create the filler part as such. Again, in part design, again the XY plane, and we start by creating a rectangular piece. We put this rectangular piece here, and first is we constrained this side to the wall. Then as the next we create, so next is we need to define the distance here, and we do it the same as we did in the previous sketch. We change to construction mode. We switch off the visibility of both parts, leaving this sketch visible. Create a carbon copy, and with the STRG key or control key pressed, we copy this into here. And now we can again define that from here to here we want to have a distance of 15 millimeters. So the next is we switch on our sketch from this part, and now you can see why I created it in the same plane, because now it's easier to copy the same here into my construction, and also define that from here to here I want to have an overlap of 3 millimeters, and let's say that is it. We need one definition, and that is we need the distance here, and this is also to have a little bit, well, yes, I want to have a little bit of an overlap, and let's say this overlap is going to be 1 millimeter only. We'll later see what comes out when it is printed and fit to the wall. Maybe I do it differently, but it should have a little bit of an overlap so that the 3 millimeters cover over this existing piece, and there's no visible gap. It looks better if it covers over. Okay, so we can close the sketch, and we can first create our pad. And now we have the problem, we don't have the same, or we don't have the proper height. Okay, leave it at 10 millimeters for the time being. So before we can now define how high this block is to be, we need to define the reference. So the reference should be the height of this pad. So let us name this pad like floor frame height, and select the sketch here again, create a pad and give it a height of equals F for floor frame height. And now we need its length, and we want to add 1 millimeter to it. And now it doesn't know what, is it millimeters or is it apples or bananas? So it needs 1 millimeter to finalize this. Good. So the next thing is we need the contour here to be the same as we have it here. So what we have is we have this draft here. We rename this draft like floor frame draft. We select this pad, again create a draft, select the face, select make a draft on the face, and first start with 3 degrees and reverse so it also goes down. So what does it want? A plane or edge plus a pull direction. Well, this here is the neutral plane. Good. Okay, it wanted a neutral plane for whatever reason. Sometimes it doesn't, sometimes it seems to want. So if we look to it from the left side, we can see we are already parallel here, and we just need to have this corner also parallel. So let's first create the fillet. Select the edge, create the fillet, and make it 6 millimeters also. But what happens if we now change this one? Because we found we have the wrong values after the first print or the first try. Now what we do is we need to reference these to each other. So let's try first with the draft. We have the floor frame draft, and we have this draft, and now we say okay, draft angle equals floor frame draft angle. Okay. Okay. So let's change the floor frame draft here to, let's say, 5 degrees. And voila, you can see it moves back to 3 degrees. So let's do the same here. We rename this to floor frame fillet and change that one, equal sign floor frame fillet dot radius. Okay. Oh, we have to make this visible. That was a little fault. Okay, so now it looks pretty good, doesn't it? What else do we need to achieve? We might finally need to tidy up this on that side a little bit. Let's look at it from this view. The standard or isometric view, and select 1, 2, 3 lines and make a fillet. Let's see how much we can do here until it goes down close to the ground and may finally look pretty nice. Good. So if we switch off these two bodies now, let's finally call this floor frame. That is our final piece without the cutouts that we need. So how do we make the cutouts? That's pretty simple because we have more possibilities in FreeCAD as part design. Now comes a point where we go to View, Workbench, Part. And Part gives us very good possibilities with Boolean operations. So first is we select the door frame and the floor frame and create a Boolean fusion out of them, a union, apply, close. So we can now say we have the fusion and we have our body. And if we now say from the body we want to subtract the fusion, remember, first from what and then what to cut away. Voila! Now we can see we have the part that we finally want to have. Relatively complex part, but done in a very simple way. So what's left over is to create an STL file from this part. View, workbench, mesh design, mesh, create mesh from shape, standard mesh as I usually take, and OK. So export. So as I said before, instead of printing it on the 3D printer and then trying to see if it fits, the first step that I want to make is I want to make a paper copy of this shape and see if the shape fits. And therefore what I'm going to do is I'm going to create a visible object. So we change the workbench and we go to a workbench I've not shown in my videos before, which is the technical drawing workbench, the tech draw. Don't think that this is a workbench where you create something. You must have created something before in any other workbench that is a visible object inside of your design, and then you just create a technical drawing out of this objects. So we start. The first thing is it wants to know what sort of a page you want to use. You could use a default page that looks like this. It's a predefined page with some space for naming and documentation, but that's not what I want. I remove that page again and I select another one, which is A4 portrait blank. In my case, I don't know whether you have that. If not, it doesn't matter, just select another one. Oh, that was a mistake, sorry. Once again, A3 landscape. Oh no, A4 landscape blank. Where is it? Here. Just need a blank piece of paper. The next step is you have to select what you want to see and the view. If you insert it this way, it will be inserted as a three-dimensional or as a isometric view. So first select how you want to view to it before you go to the page and insert that one. So select it and now click Insert View in Page. We do this with a single view. If you want to have more views like a standard technical drawing, then you could select this also, but first we do it this way. And now we see, okay, we see it in a two-dimensional view. Not really needed for my task, but just to show you what you can do is you select a line and here you select horizontal distance You can move this to your likings. You can also select 2 points. Use the STRG key to select multiple points as usual in Windows. Create another reference line. You can select this radius and select a diameter dimension. So it's going to show you that this is a 12 millimeters diameter. And what else? Well, there's no no meaningful angle, but just for the records, you can add an angular dimension, 90 degrees, something like that. You can also hatch, you can also a 3-point angle dimension, which we don't have here. We can enter arbitrary length dimensions. Let's see, we are interested in this dimension, so just take this one and put it in here. Anything you like here with these things. That's more for more complex things, but what you also can insert is an annotation. Move it, and if you select it here, here is the default text, and you can change this, but not right here. You gotta write here spacer. Well, that's it. And now we save again, and we do a normal print on our standard computer printer, whatever we have for this frame. There's a little bit of an error. I made it too thin, so I need to change the floor frame height to 20 millimeters, and then let's see how that looks if we hide these. Well, it comes out pretty well now, and it may be that the slope still is not completely correct, but we will see after next print iteration how that comes out. Let's see if it reflected here. Yes, it did. And the same happens again. I won't show you in the video. Printing, measuring, testing, and changing until it fits. The floor frame now would also fit, but while looking at the real thing, I found out that if I create it the way it is, like we can see here, it would actually block the door, because the door would tend to, or the door goes up to here, which is about 5 millimeters from the corner, or 5 millimeters from this face towards the left. So I need to cut here, still maintaining the cover of the floor. So how do we do this now? Well, I'm going to do it with another construction in part design, which I'm then also gonna cut away using Boolean cut in part. Now, how do I do this? Okay, let's start. We go into part design again. New workbench, part design, and we move the model so we can see the bottom and can select this one element, we create a new body. First we deselect everything, create a new body, have that body active. Just be sure it's underlaid in a little bit of blue. Then we select this face and we're going to create a so-called shape binder. Okay, so we have the shape binder in here. And next step is we use the shape binder to create another pad on it, which we can then finally use to cut it away. Okay, so create a sketch, use this shape binder and select OK. So one thing is, and I'm just going to show it to you by creating a very simple structure, closing. If I now create a pad, the pad is going to go into the opposite direction. That's something we have to take into account later. So let's hide this pad again and show the sketch and edit the sketch. Actually, we don't need a rectangle. What we need is we need a poly structure. And we start here. It's going to go here somehow. It's going to go here. It's going to go down, here, here, and finally going to be closed. So this is going to be horizontal. This is going to be vertical. This is going to be horizontal. And we move this here. And we have that in this corner. So let's define where we are. So next step is we go into our model, we deselect or we hide the cut to be sure we don't try to select anything from the cut while we're trying to do a external geometry. And what do we need? We probably need these lines. There's something still visible that will hide us or will hinder us. Let's take that fusion away. Okay, so we get it. Now come on, let's select them. Maybe we might once need them. Okay, so let's say this here is 1 millimeter below. This here is 1 millimeter outside. From here to here we want to have 1.5 millimeters because sorry, not 1.5, 1.6 millimeters. I'm going to tell you why. And the same here, 1.6 millimeters. And this one goes, oops, this one goes up 1 millimeter from here. Now you may ask, why didn't he select the same edges? The reason is, it turns out every now and then that people are asking, well, why is my drawing black? Or why is this happening? Why is that happening? Why is it inconsistent? In some of the cases, the reason is that if faces are face on face, directly coplanar, which means they are lying on the same plane. Sometimes the underlying geometry in FreeCAD can't properly calculate this, and you will run into errors. Therefore, I took this away 1 millimeter outside, so I'm sure it cuts away everything and does not leave an invisible wall. And here I'm choosing 1.6 millimeters. Why not 1.5 or 1.7? Well, the reason is my printer does 0.4 wide lines, and then it's 4 lines, and it's easier to calculate and it's easier to maintain the 1.6 millimeters than 1.5 millimeters. So that makes some sense for the 3D print afterwards. Good. So let's see, we have 1 degree of freedom, and that's here. That's this line, and let's go in here by, let's say, 8 millimeters. That's good enough, I think, I hope. So let's close it. Let's switch on the pad again. Let's switch on a cut again. And as I said, the pad needs to go into the opposite direction. And it needs to be at least as high as our original is. If we do that, and if we would now cut it away, we will see, oh, there's no floor here. So at this level, I want to have still a leftover of 1.2 millimeters. So what I'm going to do is I'm going to move the sketch 1.2 millimeters, and I must move it into minus direction because it goes opposite. So we can see it will now be 1.5 millimeters above. Good. Let's see what happens if we go into workbench part. And in the workbench part, we want to take the cut, and from the cut, we want to cut away the body. So select it in the right sequence, and I cut it away. Well, and that looks pretty nice. So before I go ahead, I want to let this look a little bit more smooth and natural. So I'm going to select these lines and try to apply, let's say, a 3 millimeters radius as a fillet, and change the view to a shaded view because that then looks better. Okay, we see we should do the same here to make it look more smooth. So change again from the shaded to the as is view, and oh, I forgot something. Here I should have another radius. So let's fillet this one, and we're going to take 7 millimeters, which is one more than the 6 millimeters we've used before, and that was too much. Oh, let's go back. Maybe, yeah, that's not good. I'm gonna take this away again. I'm going into the cut, into this body, into my pad, into my sketch, which is not visible. And I need to apply a real bending here before I'm doing the cut. So we try to do this on the sketch level. Take these two, and here we have a fillet function. 1, 2. So this fillet has now taken away our distance constraints, 1.6 millimeters. And we should adjust this to be coincident with this previous radius. And now we have a smooth corner. We can hide the body again, so we only see our cut. Okay, we need to recalculate with the F5 key. Sometimes you need to recalculate things manually, so that's the F5 key. And now we can go again and do some adjustments. Here we can see that was the reason why the 6 millimeters radius wouldn't have made it into here, because it would just be too thin or too small. Okay, so we have to close the sketcher also. That may be the reason why it didn't recalculate. Anyway, let's see. Trying to do these a bit smooth again. With a 3 millimeters radius. Yeah, that's quite good. Okay, this here is going to be so small, and probably the 3D printer wouldn't even make a meaningful fillet when I'm printing it. Good, so that looks like it should probably fit. Maybe it needs a little bit tweaking with the file afterwards, but that's how I'm going to actually print this in the 3D printer. And when that's done, I'm going to show you a picture how that fits finally. I'm going to save it.